So today it's about complex numbers. We just finished up the last chapter, and here is just a little comic. I'll give you a second to read it, and then I'd like you to tell me what this equals if you know. I'm going to pause for a second. So that's an imaginary number, and it's equal to I. Who knew that? Awesome. If you're like, well, you just can't do square root of -1. You're right, you can't. But you can get around it by defining it as I. Gentlemen, even if you're talking about math, you can't do that during the lesson. All right, so now I've got this equal to I. So what do we do with that? Well, there's all kinds of things that we can do with it. Like I could ask you, what's I squared? Well, that means -1, square root of -1 times the square root of -1. And you might be like, well, it's just a whole bunch of imaginary stuff. Well, it would be I squared, that's true, but you can simplify it. Have you ever noticed that when you take like square root of 2 and you times it by the square root of 2, you get the square root of 4, which is 2? When you times things together that are both under a root, do you get... It takes the root off? It's true. So, if I had the square root of 1.7 times the square root of 1.7, you should know the answer. What is it? 1.7. So, if I take the square root of -1 times the square root of -1, what's the answer? -1. Same logic. Look at the highlights here. And I know it seems like, well, it's just imaginary. All doesn't matter. Imaginary numbers are actually used in equations for electricity. So, electrical engineers, which probably one of you will be an electrical engineer. I bet you there's going to be 2 or 3 or 4, maybe even 5 of you will become engineers someday. It's pretty common. I got 2 kids that became engineers. And if you're good at math, which you guys generally are, you're in an honors math class, some high percentage of you guys are going to become engineers. Within the engineering world, the electrical engineers are pretty smart. They're some of the higher level engineers. You know what's considered the hardest engineering? Chemical. Chemical engineering is considered the hardest thing because it involves, you have to not only be able to handle engineering, you have to also be masters of like all the biological side, because like you have chemical mixing with another chemical. That sounds like a science class, doesn't it? And you got to like understand what happens when this reacts with that. And so, all right, so electrical engineers use this all the time. And you got to know that I squared is -1. It's like the big fact that's going to become really important later. All right, so how do you end up actually getting things that are imaginary in the real world? What if I said, what are the roots of this? Would you agree it does not touch the x-axis? So up until now, we allowed you to just say it doesn't have any x-intercepts. It doesn't have any roots. There is nothing that makes this equation equal 0. From our last unit, if I told you this was 2, 1, and I said there's no stretch, it's just a normal parabola, you should be able to write me the equation for the parabola. Stretch yourself to remember that equation for the parabola. Cannot afford to forget stuff we already learned in this class. There it is. Could you make a mistake like forgetting that it's -2? Yeah, you're human. You're likely to make a mistake like that. How many of you actually remembered it though? Okay, cool. There's the equation for it. Now if I said what makes this equation equal 0, I mean the x-intercepts where y equals 0. If you try to find that, you're going to end up having an answer that's got the square root of a negative in it. Remember the deal where if you can factor it, you should, but this one wouldn't factor. And then you'd use the quadratic formula to solve it, and then you'd get a square root of a negative. That's what it's all about today, is square roots where they come out negative. All right, so let's actually do this. Would you please multiply this thing out? Multiply this all the way out. Get it into general form. And you'll try to factor it. It won't factor. Then use a quadratic formula. Then you get the square root of a negative. And that's the moment where I get to start showing you how to handle that when you have a square root of a negative in there. So algebra 2 isn't that hard if you know algebra 1. If you're still struggling to square that, then your algebra skills are weak. And I give you something called the first 20 to help you over these things. But some of you don't think that's important. Some of you just keep getting D's on it and are like, yeah, whatever. It's moments like this where if you don't know algebra, you wouldn't have been able to get to this. Could you make a mistake? Sure, you're human. But if you didn't have a clue what to do, you're terrible at algebra, and algebra 2 is going to kick your butt. How many of you got the same thing I did? Or maybe it's wrong. I don't know. Say, how many of you got the same thing I did? Okay, almost everybody. Cool. Now, you might try to factor that and think you've got it, because you're like, I got it. It's x and x, and it's got to be, oh yeah, it's got to be a 5, so it's a plus 1 and a minus 5. Really common mistake. Do you get that when you multiply it out, this times this does not equal positive 5, so you tricked yourself into thinking it factored. It does not factor. This one doesn't factor. You might think you've got it with this, but it doesn't work. So then what do? X equals negative b. Everybody write the rest of that formula. It's huge, this unit. You got to know the quadratic formula. Plus or minus the, say it if you know it, square root of what? B squared minus 4ac. And it's all over. Excellent. If you didn't know that, know it. You have to know it. See that blue part there? That's going to become a big deal, because if that blue part is negative, you got an imaginary answer. Square roots of negatives exist only as imaginary numbers, but we still have to, like, we can't just say, no solutions. We have to get the answer. All right, so now let's put in b. You all know what b is, I hope. It's up in here. There's a, b, and c buried in there. And for ac, from my experience, almost all the mistakes in this equation are made underneath this big blue square root right here. That's where people are going to mess up. There, I just made it what I call the skeleton form of the equation. And now I know A is 1, B is negative 4, C is 5. Put those all in, simplify it as much as you can. If you ever notice, there's only one spot to put C. Negative 4 becomes 4, plus and minus the square root of 16 minus 20, and that's where we get the problem, all over 2. 4 plus and minus square root of negative 4, all over 2. Can I stop and just say, oh, there's no solutions? No, we have to simplify it more. So does anybody know what to do with the square root of negative 4? Cool, then you're going to learn something. Yes, you know? Maybe. Yep, you're going to put in imaginary. What do you think we should put? A good guess. Imaginary is part of the answer, but it's not minus 4. All right, yes?
Is it to the root of?
Not times it. It's not, kind of, but you got to simplify.
To the root of 2 because you take up...
The root of 2? No.
Or not the root,
You got it, you said it. So what's the answer?
square, like... no, I don't think that.
Yes, you had it. 2. Just 2.
Oh, okay.
Not the root of 2. We already did the root of 4. The root of 4 is 2, so then it's 2i. All of that right there is 2i. Yes?
Can you make it square root of negative 1 and then
the square root of 4, and then make it 2.
I like exactly what you said. That's exactly how to think about it. Square root of -1 and the square root of 4, which is how we got 2 and I. It's just that you always put the I last. 2I. Cool. Now we have 4 plus and minus 2 imaginary over 2. And you might think, oh, that was a lot of hard work, and you're not even done yet. Because some kids that are really like terrible at their basics are like, cancel the 2's. No. This is part of an add problem on the top. You cannot cancel that 2 out. But, what's my favorite saying? If you can factor it, you should. Factor that top part. There's a 2 in both parts. Factor it out. Really critical kind of factoring. A lot of people think 2 parentheses whenever you factor. Nope. You look for the GCF first. What's the thing that's in both of them? 2. And then what's in here? Plus and minus, and there must be something here, and there must be something here with the black arrow and the blue arrow. Really what's happening, in case you didn't know this, is this gets divided by 2 and this gets divided by 2. So that tells me what goes in there. There's a 2 in there. How many of you had a 2 right there? Awesome. And then I'm dividing 2I by 2, and it's just I. And now those 2's cancel. Holy cow, that's a lot of algebra. Yep, and you signed up for honors. Otherwise, if you were in regular, you wouldn't even touch this thing. You'd just say square root of a negative, so there's no answers. It wasn't wrong. There isn't any real answers, but these are the imaginaries. This is called, the topic is called complex numbers. I am kind of an expert on the ACT and what's on it. This is on it. Not saying it's on there all the time, but out of the 60 questions you get on the ACT, this is one of the most complicated kind. I mean, heck, they're called complex numbers. All right, so let's say we had another one like that, and you do the quadratic formula all correctly, and you get this. Would you please simplify it like we just did? You got done with the quadratic. You remembered that. Is that a cell phone in your lap? Yes. Oh, good. Thank you. Sorry, I just thought I saw you putting the phone away. Do you know how to simplify underneath that square root? Because that's what you need to do. And one kid, I think it was Liam, said, can we think of that as 2 square roots? Yes, that's the perfect way to think of it. 2 square roots. 4 times 4? No. Square root of -1 and the square root of 16. And then the square root of 16 is actually, and this is actually I, so it's 4I. And then you stop and rewrite it because it's getting messy. 2 plus and minus 4I over 8. Can you simplify it again? Some small subset of kids think you can just make that into 1/2. Nope, you can't, because it's part of an add-subtract problem, so you have to do the old factoring trick. If you can factor it, you should. And then the top factors a 2 out, and the bottom factors a 2 out, because 2 times 4 is 8. And remember, if you can factor something, you should. So the 8 gets factored into 2 times 4. Then those 2's are ripe for the cancel. But I got to know what goes in the parentheses first, so that you don't feel like I'm always calling on you. I'm going to get the dice to call on somebody. What goes in the parentheses? 4, person 3, and that is Brooke. What goes right here and here?
1 plus or minus 4I.
1 plus or minus. So close. If I put a 4 there and I multiply this out, I'll have 2 and 8. So what should be there, Brooke? 2, there you go. Now again, you can multiply this out to make sure 2 times 1 is 2, 2 times the 2i, 4i. Cool. That's how you factor that out. I guarantee you're not the only one that oopsed on that. Then the 2's cancel, and there's your final answer. I know it looks kind of messy, but 1 plus or minus 2i over 4 is a complete answer. Because you can't factor it anymore. So you can't cancel anymore. And so you must be done. All right. That is complex numbers. Where do they come up? If I asked you what the roots of this are, you'd be like, well, there they are. 3 and 4, or whatever they touch at. But if I ask you what the roots of this are, you'd be like, there aren't any roots. So then they are imaginary. So then you could write the equation for it, stick it into the quadratic formula, and find the roots that way. All right, there's my prelude to setting the stage for these notes. Now let's go into the rest of the notes. Find this page. What is a complex number? Well, square root of -1, because that's the easiest square root of a negative that there is, and they called it I. This is actually a pretty decent joke. Oh, he has an imaginary friend. Okay. I is just I. That's super simple. I already told you what I squared is. You got a short-term memory? It means the square root of -1 times the square root of -1. So what's the answer? -1. What's I to the third, though? Yeah, we might put this on your test and ask you, like, what's I to the 7th? And you'll have to be, like, doing it this way. So let me show you. I to the third would really be I squared times I, wouldn't it? Isn't that the same as I to the third? And then isn't I squared -1? So this is -1 times I. That's the answer. Negative I. Isn't that weird? The first answer is I. The second answer is -1. Doesn't even have an I in it anymore. The third answer has a negative I. It's almost like there's no pattern to this. I to the fourth, if you haven't figured this out yet, you go I squared times I squared. Because you always try to bring it back to I squareds, because those are simple. I squareds are -1s. So that's really -1 times -1, which is really what? 1. Now, do you get that we keep changing the answer? It was I, and then it was -1, and then it was -I, and then it's 1. Now, on a test like the ACT, you have a calculator the whole time. And I don't know if you know this. I don't need you to bust your calculators out right now because we're not going to use them much. But on the ACT, you could. Did you know that there's an I button on your calculator? There is. It's right above the decimal point. You've all used the decimal point like 8,000 times. Right above the decimal point, there's a little I right there. So if you want to know what I to the 7th is on the ACT test, just grab your calculator and type the I button, which is right above the decimal point. Put it to the 7th and it'll tell you. It's pretty slick because the calculator's been programmed to know that I is the square root of -1, and then it uses those rules. All right, so what's I to the 5th? From the thing I just did, you should be able to go, so you want me to break that up into a bunch of I squareds, right? Yup. Can I do 3 I squareds? No. I guess I can just do an I, though. Or I to the 1. That's what you do. You just keep on breaking it up into I squareds. Would you please finish these last 2 and then compare with the kid next to you? I'm going to pause for a sec. Okay. -1, which makes 1. I. Wait a minute. Didn't we have that answer before? We had an I the first time we did it. I was I, of course. And then the I to the 5th is also I. But in my opinion, don't just try to memorize this. But it is a repeating cycle. I noticed it. I think Liam noticed that. This one, I squared times I squared times I squared is -1 times -1 times -1 is -1 again. And so it's just completing this like little loop. It's I and then -1 and then -I and then 1. So I can even make the prediction. This third one must be the third one in the series. That. It must be -I. And it is. Yes?
Does that mean that, in an equation, I to the power of 3 and I to the power of 7 have the same effect on it?
Exactly. Yes. I know, it's weird. They are equal. They're the same thing. I to the 1 is just I. And I to the, wait a minute, did you say I to the 5th?
I to the power of 3 and I to the power of 7.
Oh, okay. Just like regular I and I to the 5th come out to the same thing. I to the 3rd, which is here, comes out to the exact the same thing as I to the 7th. So yeah, they'd be the same. Okay. Enough about that. We already did these, but do you have a short-term memory? Can you answer these? You might be like, but I don't know the square root of 7. So leave the square root of 7 in your answer. But you can't just say that the answer is square root of -7. You cannot leave a negative under the root. That's like a problem. The answer doesn't have the negative under the root anymore, and it does have an I. How many of you knew it was I root 7? Okay, if you don't get that, let me just show you quick. I break it up into 2 square roots, always. Always make 2 square roots. Square root of -1 and the square root of 7. And then that one's actually defined as I. That's why your answer is I root 7. If you put root 7 and you put the I after it, it's fine as long as it doesn't creep underneath the root. Here's a really common mistake answer. No, that's wrong. You can't have the I under the root. The I has to be clearly outside the root. Now, if you keep your I outside of the root, technically I could accept that answer, but it sure looks like you're saying the square root of 7I. So it's better to put the I in front of the root. Okay, now some of these are easier than others, like square root of -4, that one comes out pretty nice. But some of these have to be simplified more. Like this one's actually 3 square roots. Some of you won't be able to sleep until I tell you this is 2I. Okay. This next one, 3 roots. Square root of -1 is one of them. And then there's another perfect square. What should I break 24 up into?
12 and 2.
That is a true statement, but neither one of those are perfect, so therefore pick something else. Liam, you can do it.
I got an answer where it's...
Yes, I know, but just rethink it and go, ooh, I could have started with different numbers than 12 and 2.
Oh,
What could you have started with instead that would have worked nicer?
6 and 4.
6 and 4. There it is. And now this is an I, this is a 2, and this is the square root of 6. Now I would recommend you put it 2I root 6. Now it's valid though to look at the way Liam did it, because a lot of you are going to have this happen. You're going to be like, you notice that it breaks into root 12 and root 2, and then at least you're smart enough to remember that it's got the negative. So what's wrong with this? Well, neither one's a perfect square. If I were you, I'd just start over again. But you could have broken this up into root 2 and root 6 and then put these together and made a 2. But I think it's easier to just start over and go, neither one of these is perfect. I'm going to pick something else. It's just a little faster to go root -1 and root 6 and root 4, because that one's perfect right out the gate. 2I root 6. Okay. Now we have to add and subtract them. Square root of 50, that's root 25 and root 2. And don't forget the square root of -1. 7 plus 5i root 2. Can you add these? Do they look like they're like terms? No, so you just leave them the way they are. They're quite different. You can't add them when they're like that. It's like adding A's and Y's. They're just different. Apples and yams. You can't say, I have 12 apple yams. No, can't do that. Dealing with square roots, there's a lot of them. Again, an ACT skill that a ton of kids are not good at. There isn't even a square root of a negative here. Do you get there's no I? It's just root 4 and root 5, which is really 2 root 5. And those are not like terms, but they could be factored. If you notice this, extra bonus points for you. You could factor out the 2. Do you have to? No. I do say if you can factor it, you should. Do you get there would be 2 2s? And therefore it could have been factored out? Awesome. Whenever I see a kid do that, I'm like, ooh, extra sharp kid. Notice that it could factor, but you don't have to. Sometimes, though, it helps. All right, then there's this one, 11 plus minus square root of 36 is 6. Don't think that there's a negative in the root. There's no negative in the root, so there's no I. If you thought there was an I in this problem, they were just checking you. No, there's no I. Can you leave it like that? No, you actually have to get the answer, because 11 plus 6 is doable. What is 11 plus 6? 17. And then, what's 11 minus 6? Those are your 2 answers. It's very common for kids to just get used to leaving answers like that. No, you left me a math problem. You have to do the math problem. 11 plus 6, 17. 11 minus 6, 5. Those are your 2 answers. This is pretty dense stuff. So many little things you have to know. So we practiced this right before we dove into the notes, and I showed you where it came from, the quadratic formula. Can you simplify this all the way down? I want to warn you that today is one of those days where we have covered so many things in the first day. You might leave feeling a little confused because I covered so many topics. Honestly, right now, if you were to be taking the test, I've already covered 5 of your test questions. And you don't get tested for like a week and a half. Okay, so I'm covering so much stuff, but I have to because there's a lot to this chapter. Okay, start here. Should know how to get the I and what's left. I'll get you to the next line. Two plus and minus 4i. If you get good at this, it'll start going quicker. Then the 2 factors out, because if you can factor it, you should. I factored the 6 into 2 times 3. I factored out a 2 for those of you that kind of suck at that. Just draw a little divide by 2 under each of them. That'll tell you what to put here and here. Those are gone. This you can leave like that. It's more messy if you try to do it separately as 1 plus and 1 minus. It's not illegal, but it's best to just leave it like that. There, I helped you with that one. That should inform you a little bit. Everybody, take a little mini test. If you can simplify that one and then compare it to the kid next to you, wait till they're done, then you get a lot of complex number stuff. I'm going to pause for a second while you try to simplify that. Okay, you're going to do this so often, it's going to be on like probably once a day, and then you'll finally get tested on it. You should have said root 9, root 3, and root negative 1. Why? Because that's a perfect square, 3. That's something special, I. That one can't be simplified, so you'll leave it. 12 plus minus 3i root 3 all over 9. And if you can factor it, you should. 9 factors into 3 times 3. And I bet you the top has a 3 in it, doesn't it? Look. So that way this 3 will get canceled off later. You can go, oh, it must have a 3 in it. It does. They both have a 3 in them. So I factor that 3 out. It's called the GCF, greatest common factor. If we were in Texas or California right now, we'd be calling it the GCD, greatest common divisor. Divisor and factor mean the same thing, just so you know. We call it greatest common factor, but in other states, they call it GCD, greatest common divisor. Just wanted you to know that because you know your graphing calculator. You go look up GCF, doesn't have one because it has a GCD. And it's the same thing. Okay, so back to this. These are going to cancel if I can figure out how to factor out that 3. It leaves a 4 plus minus I root 3. Then that can cancel that, and boom. Who got to that without any help? Sweet. Then my work here is pretty much done. So that's the start of what are called complex numbers. Complex numbers aren't just complicated numbers. They're parts that have imaginary parts to their answer. Like if I say 4 plus I, it's got a real part, which is the 4, and it's got an imaginary part, which is the I. That's what makes it complex, because it's real and imaginary in the same number. That's a complex number. Okay, now you have a Schoology quiz. Would you please find it? I think I enabled it. Is it openable? Can you open it and start it? Okay, excellent. And that's your homework for today. You have it. Well, let's see how much time you have left. We're back to an A day, Monday, out of here at 10. So you got about 18 minutes. No, wait. Wait a minute. I'm wrong hour. We're out of here at 11. Okay, so you still got about 18 minutes, 17 maybe. Work on that Schoology quiz, please. That's all I got for you for the video for today. Save.